So when you think about video, you're probably thinking about, the buffering wheel on your phone.
Yeah, exactly.
We're not talking about that today. We're talking about professional broadcast-grade video, the kind where every single frame matters.
And we're going to deep dive into the hardware that makes it possible to move that kind of signal onto, well, the modern internet.
This is a huge transition in the industry.
It is. Our whole mission today is to understand the engineering behind that move, and we're going to focus on one specific device that's kind of an unsung hero here. It's the Thor Broadcast H-8ASI-IP gateway.
Okay, so a gateway. Let's unpack that. Looking at this thing, its job seems really clear just from the inputs.
Right.
It takes up to 8 DVB-ASI streams. And ASI is, well, it's a very specialized broadcast signal.
It is DVB-ASI, Digital Video Broadcast Asynchronous Serial Interface. And that input is so important. It's not just some old connector. No, ASI is the standard that basically wraps and protects the core of digital TV, the MPEG-2 transport stream. It's the last line of defense for that signal's timing and integrity before you throw it onto the wild west of an IP network.
So you have these 8 specialized inputs coming in, and then the output is just one standard gigabit Ethernet port.
Huh.
An RJ45.
That's it. It's a dedicated one-way street.
Just ASI to IP.
Only that. But the sheer amount of data that one little box can handle is what's truly incredible.
Yeah, let's talk about those numbers. The capacity is huge.
It is. So each individual stream can be up to 108 megabits per second. But the whole device, all 8 channels together, can handle a total of 800 megabits per second.
That is a massive amount of data to be pushing through a single network drop without losing anything.
And that's the measure of professional gear. It has to work flawlessly, not a single dropped frame.
Okay, so that brings up the big question, right? The protocol. If the whole point of ASI is to protect the timing of that MPEG-2 stream, how does this box put it onto a network that, doesn't guarantee timing or even delivery?
It does it using TS over UDP.
UDP, not TCP. So there's no error correction.
That's the trade-off. UDP, User Datagram Protocol, is connectionless. It's incredibly fast, very low overhead, which is exactly what you need for this much real-time video.
But you're taking a risk.
You are. The equipment on the receiving end has to be smart enough to handle any potential packet loss, which is a big engineering problem you just don't have in the clean ASI world.
But the payoff for that risk must be huge.
Enormous distribution power. Because it's using UDP, the output supports both unicast and multicast.
And multicast is the magic word here.
It changes everything. If you need to send that feed to, say, a dozen different places, monitoring stations, affiliates, whoever, you don't send a dozen copies.
You just send one stream.
One multicast stream. It's unbelievably efficient for delivery at scale.
And what I think really seals this deal, the thing that shows how well it bridges these two worlds, is that you don't even need special hardware to receive it. The IP stream it creates is so standard, you can actually just open it up on a regular computer using VLC.
Yeah, the VLC media player, it just works. That really does close the gap between, a dedicated broadcast facility and a modern IT department.
And that capability, I assume, is reflected in the price.
Absolutely. This isn't something you buy at a consumer electronics store. It's a heavy, robust, 4-kilogram rack unit. The price today is $5,295.
Wow.
And you're not just paying for the metal box. You're paying for the guarantee that 800 megabits per second of pristine video stays perfectly synchronized.
So the takeaway here is pretty clear. To move these massive, high-quality signals, you absolutely need these specialized gateways. They keep the broadcast standards perfect while giving organizations the scale and flexibility of IP networks.
It really makes you appreciate the hidden costs of reliability, and it leaves you with a thought. Well, if a single device that handles just 8 channels costs over $5,000, what do you think the total unseen investment looks like for a major national network? One that has to route thousands of these signals all over the globe every single hour with perfect sync. That hidden infrastructure is something to think about next time you just flip on the news.